Hi guys, welcome, and today we're going to be learning about finding the area of parallelograms. So I'm not sure how much background you do have with parallelograms, but they're very similar to rectangles. In fact, a rectangle is just a special kind of parallelogram where all of the corners are 90-degree angles. In a parallelogram, the corners don't necessarily have to be 90 degrees. So what we can do is we can compare. Okay, so we're going to compare the two, but first we're going to start with the rectangle. So you guys know that the area of a figure is the number of squares, or the square units that it encloses inside of the perimeter. So when we find the area of a rectangle, so say our rectangle is here, we could call this the base and this the height, and our formula to find the area of a rectangle would be area equals base times height, where B is the length of one side and H is the length of the other side. You just multiply the two together to find your area, and then your answer is always going to be in units squared. Your answer is. So to find the area of a parallelogram, the formula actually follows the same rule as a rectangle. There's just one difference though. The formula for the area of a parallelogram measures the height as the length of an altitude of the parallelogram rather than a side. So what an altitude is just a line segment that's perpendicular to the base. So notice that this word perpendicular is super important. So perpendicular meaning that it sits at a 90-degree angle instead of at some other angle. So let me show you what that looks like. The altitude is actually right here, as I was saying, where it forms a 90-degree angle to the base of the parallelogram. So as students, we're sometimes tempted to think that we need to do the base times like the length of the side over here on the other side to find the area of the parallelogram, which is incorrect because this angle is not at a 90-degree angle. It's not going to actually give you the accurate length of this side right here. So our altitude would actually technically be just a little bit shorter than that. So you always want to use the base and then the height being the altitude. So keep that in mind, and we will go ahead and do a few examples. So let's go ahead and start with example 1. It says find the area of the parallelogram. Here I have a parallelogram with quite a few measurements. I've got a base measurement at the bottom of the parallelogram of 8 inches. I have a side measurement of 5 inches, and then I have what looks to be like an altitude or a height measurement of 3.5 inches. So let's see if we can work our magic on this to figure out the actual area of the parallelogram. So I'm going to start by bringing up that formula, which was area equals base times height. Area equals base times height. So now we just start substituting. So we're going to find our base. So over here on our picture, we know that 8 inches is our base. So I'm going to go ahead and substitute 8 here. And then our height is going to be a little bit harder to discern because we need to figure out if it is the 5 inches on the side or if it's the 3.5 inches that makes up this altitude. But if you recall, when we were just talking, we determined that our height is going to be right here, which is our altitude and not a side. So we're going to multiply it by 3.5 inches. So our area ends up equaling 28 inches, and because we're working in 2 dimensions, it's inches squared, or inches to the second dimension. Okay, so our next example actually asks us to find the area of a parallelogram with a base length of 3 inches and a height of 5 inches, but it doesn't give us a picture. So if you are more of a picture person, you could draw a sketch. However, you don't have to. This is actually even easier because you don't have to figure out, if we have an altitude or if we don't have an altitude. We do know, though, that we have a base and a height. So all we really have to do is substitute. So my area equals base times height is the formula we're working with. So a base length of 3 inches, I'm going to go ahead and substitute in my 3 right here. And then I'm going to multiply it times my height of 5 inches. So 5 inches goes right here. And when I multiply them out, I get 15 inches squared because I am in the two-dimensional figures, or this technically is an inch times an inch is inches squared. So that is an answer for our example number 2. Very simple. So moving right along, let's go on to example number 3. And with example number 3, we're going to be doing a little bit of coordinate geometry. It tells us to draw the parallelogram and find the area. So first we have to actually draw the parallelogram. And the way that we're going to do that is using these coordinates that they give us over here. I noted as I was pulling up a graph to use for this example that all of these values are positive, and in the second column they're all positive. So this means that our entire image is going to be found in that positive quadrant, which is quadrant 1. So that's something that you should be able to discern if you just pay a tiny bit of attention when you're just taking a first glance at your coordinates, what kind of signs are on the front of them. So let's go ahead and start graphing our coordinates. Remember that we walk before we ride. So we walk to the elevator, then we ride the elevator. So let's start with coordinate A. Coordinate A is at 0, 0, which makes it super simple. Right here is our origin, our 0, 0, and that is A. So I'm going to go ahead and put A there. Let's move on to our coordinate for B. B is 3, 0. So we're going to walk 3 and then we're going to ride nowhere. So we're going to walk over to 3 and ride nowhere. So here's point B. And I can go ahead and cross that one off. And now let's move on to point C, which is going to be located at 4, 3. So C means we walk 4 and then we ride up 3. So we end up here for C. And finally for D, we're going to walk 1, ride 3. So I'm going to walk over 1 and then ride up to the 3rd floor. My Y value is 3 again. So I'm going to cross that off. So then you can see that this has kind of formed our parallelogram. Let me go ahead and see if I'll use a bright color, draw it in for us. Connect my A, B, C, D, and then D back to A. And there's our parallelogram. So we need to bring back up our formula in order to find the area. Area equals base times height. It doesn't tell us what unit we're working in, so there's no way of telling, but whatever unit it would be units squared. So we can maybe just put units instead of putting inches squared or centimeters squared. So the first thing we need to do is figure out what our base is. So the length of our base. And the way that you would do that is basically just looking, here's our base. It goes from here to here, A to B. So going from 0 to 3, and that's a length of 1, 2, 3. So our base length is 3. I'm going to substitute a 3 right there. And then to find our height, don't forget that we need to use an altitude. So we don't want to use, the slant over here. We want to use actually this dotted altitude that goes from 0 all the way up to 3. So this also has a height of 3. So to find my area, all I need to do is multiply 3 times 3 to get 9. And then whatever units it is, we don't know, so I'm just going to put square units. And that is how we find the area of a parallelogram when it's given to us as coordinates rather than it is given to us as a picture or just as words. Okay, for my last example, I'm actually going to have you guys solve it on your own. This is not one that I'm going to solve with you. In fact, I would like for you to solve it on your own, and then you're going to show me your work and hopefully be able to move on to the next step of our lesson. So my question is, Mrs. Funmayer, who works in our office, has a garden shaped like a parallelogram. And what I want you to do is find the area. However, I've given you this picture that is a scale drawing. So the scale drawing has the parallelogram showing you with a base of 8 inches and then a height of 3 inches. But the actual measurements of her garden are a little bit different. So what I've done is put a unit scale up here at the top where you need to, go ahead and figure out what, the equivalent of 8 inches would be according to the scale, and then also what the equivalent of 3 inches would be according to the scale before you can figure it out. Or maybe you'll find a different way to do it, but that is how you get started. So I wanted to make sure that you saw that before I set you on your way. So go ahead and figure this one out, and when you're finished, bring it up to me to see if you have done it correctly.